Hey everyone, this is FixRiff, and today we have this Apex EB832 in for repair. This unit is actually one of several that came in from this one customer who apparently had a lightning strike at their house. It took out all of the Apex equipment. I have the head unit here. I already looked at this head unit and it's not repairable. Pretty much everything inside that head unit got fried, including the main controller. It's just not worth doing anything to something that has pretty much everything that needs to be repaired or replaced. And now I am hoping that I'm going to be able to salvage the two EB832s that I also received from the same customer. They all have the same problem. If you plug them in, as it is right now, nothing lights up. The Neptune logo doesn't light up. None of these lights come on. I don't hear anything clicking inside, so the unit is as dead as it gets. I have no idea if this is going to be repairable or if it's going to be worth repairing, but I'll give it my best. So let's open it up and see what's inside. And let's see what we have. Well, this has a newer 12-volt power supply, so presumably that one is supposed to be okay, although we obviously don't know. The 24-volt power supply is still the same type. All right, so let's plug it in real quick. I want to see if the green LED on the 24-volt power supply comes on, because if that power supply is dead, that is the power supply that actually provides power eventually to the main controller. And if this one's dead, then it would explain why the rest of the EB832 is dead. So let's take a look. The power is on, and you can see that the green LED inside of the 24-volt power supply is not on anymore. Okay, that's encouraging. We can handle problem with the power supplies. It's much harder to take care of all kinds of problems that are happening on this board. Oh yes, and I actually heard a click, which means that the 12-volt power supply is working. Here's the fan coming on. The fan is not supposed to come on. I'll have to see what's going on, because the fan is not supposed to be on until the unit is actually hot. So something else is going on. All right, well, let's keep on disassembling. Finally, Neptune's not doing the hot glue anywhere, including those screws, so easier to take out. All right. Uh-oh. Well, there is the damage. There is the damage. All right, let's see what we see on the other side. This damage, in fact, you can see that there are two spots that are burned. This area and this area. So there are two things that are probably going to be bad or wrong with this unit. All right, are you ready? Let's flip it over and find out what's on the other side. Okay, so the 24-volt power supply. All of this came off of the 24-volt power supply. All right, so I removed all of the bad components here, all of the bad resistors, the transistors, the diode, more resistors, and I also removed the power MOSFET. Now let's test the power MOSFET to ensure that that is the one that was, in fact, causing the short. Oh yeah, it's shorting on every single pin. So this guy is gone. And here where it used to go, nothing's shorted anymore. All right, good. Now the challenge is going to be finding all of the components to replace here. Okay, let's start by removing all of the old solder. All right, that looks better already. And adding some solder to all of the pads. Okay. Next, what I would like to do is, or I would like to start with, is replacing the MOSFET, because that's the biggest piece. I have a brand new one here. Let's put it in. Before I solder it in, I need to make sure that it aligns with the heatsink, and I will actually bolt it in. All right, now it's nice and secure. And it can be soldered to the board. Just like that. I will cut the excess at some point, but now we need to move under the microscope and put all the other components back in place. Okay, let's get started. One resistor at a time. I might have put too much solder on this, but that's okay. Nice and easy. Now next 5. Looks like this will need a little bit more solder. Just like that. All right, this array of resistors is done. Now let's move on here. I think we're missing a diode here. Just like that. Now moving on. We need some transistors. Since I have the bottom one, let's install the bottom one first. Now the last transistor.
Perfect.
And I think the only thing left would be this missing resistor as well. I'm gonna use this guy on it. And that should do. Alright, so we replaced, I don't know, about almost a dozen components. Six resistors over here, the MOSFET, a diode, two transistors, and one more resistor. So at this point, all that I could visually see that was wrong with the power supply has been fixed. Let's stream the MOSFET a little bit. And now, before we plug it in, let's test to make sure that the short's not present. Nothing's guaranteed to work. But at least we hopefully won't get a short. Oh, and by the way, this is the fuse. And the fuse is still conducting. It is interesting how a power supply that's hit with a lightning burns out pretty much entirely, yet the fuse is perfectly fine. Alright, so we are, back to our normal state. Let's plug it in and see. The EB8 is not going to work yet, or EB832. The question is, will we get the green light on the 24-volt power supply? Let's plug it in and find out. No, not a chance. Not yet. Okay, so while I'm looking at why this is still not working, I've noticed something interesting inside the power supply. At first, see this fuzzy? At first I thought that the fuzzy is some type of a bug inside. I've seen that a million times before. And then I realized that it's not a bug. This is actually yet another component that blew up. I think it might be, actually I have no idea what it is. I'll need to find out. I think it might be a capacitor, but that's completely gone. So we'll need to find out what that is and have that replaced too. So upon further investigation, it turned out that the reason the power supply is still not working is because two more resistors are not conducting properly anymore. I already removed this one because I was testing it, and it turned out to be completely blown. And also this guy. Off it goes. Okay, let's add some fresh solder to this. And let's put some fresh components on it. All right. So how many more components we will have to replace before this power supply starts working again? Okay, so I have ended up replacing a lot of different components on this power supply. You can kind of see the mess that's going on this pad here. So we have the power MOSFET. We have a blown up capacitor. And look at the row of components that I had to remove. and replaced. So in addition to the components that I replaced with the camera on, I also ended up replacing the following. I should have thought of that earlier, but didn't think of it right away. So let me zoom in so that we can see this whole area. I mean, most of this whole SMD part, most of it got replaced, right? So all of the resistors, the transistors, the diode, and all the way to the PWM controller. The PWM controller, I should have thought that about replacing it earlier, because it kind of makes sense, because the power MOSFET, the main power MOSFET that got blown real bad, is controlled. The gate of that MOSFET is controlled by the PWM controller for sure. So when the MOSFET blew up, it definitely took out the controller as well. So we had to replace the controller too. But now I think we have the power supply actually working. Let's make sure that that's the case. Let's plug it in. And the LED, you can kind of see that the LED is working. And I've heard rather the clicks right away, which is actually great news. What this means is that the 24-volt power supply provides power to the 12 volts aqua bus, and then provides power to the main controller, which in turn immediately turns on or off the relays that are on the EB832. So I think we actually may have a mostly working unit. The only thing remaining right now to fix, unless there is more wrong with this unit, is the CAN transceiver that we've removed earlier, and it's just gone here. So let me get a brand new CAN transceiver for this. All right, so let's get a brand new CAN transceiver. Something like that. And let's install it where it belongs. I'll get under the microscope, clean up the area, and install the transceiver. All right, the usual. Let's clean up all of the pads. Remove all of the hard to melt and let it solder. Now let's add nice and clean leaded solder. A bit of cleanup of all of the gunk. This looks fairly clean. A little bit of flux. And let's put it on. I'm gonna have to use my soldering iron here as well, because there you go. Now some final cleanup around the area, although it's actually fairly clean as it is, because I'm using a really nice clean flux. It's fairly good. All right, that looks real good. Okay, so this is all partially assembled. Let's plug it in, see if we get any of the LEDs turned on, and then finally test it with the main unit. Okay, the Neptune LED is flashing. That's a great sign. Let's plug in the head unit, and that is the biggest test. If we have the COM, we're good. Looks like we're connected to the head unit. Now let's see if any of the LEDs turned on. All right, I think we got it. I can hear the clicks of relays. Every single one of them. Okay, that's great. So I think we got most of this working. Okay, so if you thought that this EB832 being struck by lightning is actually fixed now, you would be wrong. You can kind of see why. I just removed one of the two controllers that are responsible for managing the individual outlets. It turned out that although all of the outlets were working, turning them on and off was working as well, voltage readings were not correct. Voltage was showing 1 volt AC coming in, and no matter what I did, it wouldn't budge, it would not change. It turns out that the pins responsible for voltage reading on the right controller here are shorted. So we start with this component over here. I also removed it for testing so that it wouldn't get in the way. I removed this component. These two pins were shorted and they were not supposed to be shorted. I traced them to the controller, and sure enough, removing the right controller removed the short as well. So all this controller, while not completely and utterly dead, it still has a couple of pins that are responsible for voltage reading being shorted. So now we have to replace the controller as well. All right, so I've replaced the controller. This controller, the old controller is gone, so this one's new and in place. Clean things up. Now it's just a matter of reprogramming, as I mentioned before. Neptune provides programming interface under this outlet, so it should be a fairly straightforward process. So let's get that done. All right, so the program is in place. Let's see if we can program the controller and test if it works. Transfer complete. And let's test. All right, we're plugged in, and look at this. I think it worked. Check this out. The voltage reading is now correct. And we can try to switch the outlets, especially the ones controlled by the new controller. Everything is clicking. I think it's working. I think we got it. Well, this repair is done, finally. This was a very, very complicated and tedious repair because just so many components got destroyed. Check this out. Let me just create a small pile of everything that was replaced. All right, just take a look at this. Power MOSFET, main controller, CAN transceiver, a large capacitor, an unknown number of resistors, a PWM controller, diodes. There is more than a dozen of components that went bad during this event. All of them had to be replaced, everything had to be tested. But now, this EB832 works again, and it works as it should, if not better. Well, this completes the repair. If you enjoyed it, please like and subscribe, and I will see you next time.